in order to understand redirection and piping, we have to have some notion of what standard output is. You could say that most running Unix programs produce output. So what is output? Output is typically what you see printed on the screen by the program. Let's look at a program that produces output and look at a program that does not produce output. The ls program clearly produces output. Those words that you can see on the screen streaming down the left hand side, they are the output of the ls program. I know this sounds really basic, but we have to be technically very precise here so that the rest of the chapter makes sense. Now let's have a look at a program that does not produce output. I could type in cd ... Now I just got my shell prompt back again without any intervening output. Admittedly the shell prompt is changed, but that is a function of the shell itself, not the cd program. More importantly, the cd command did its work silently. There are a few such programs like copy, move, remove, mkdir, and so on. Such programs produce no output at all unless there is some kind of error, in which case they tell you what the error is. If you don't see any output, you assume that the program completed correctly. So, with that little demonstration of what output is, let's continue. Importantly, and this is the new concept for this chapter, output can be redirected to one of two other, well, what we can call places, I suppose. The first of those two places is output can be redirected to a file. This means that instead of the output appearing on the screen, a new file is created and the output that would have gone to the screen is stored in the file instead. This file can then be examined, edited, copied, renamed, etc. Alternatively, the output can be redirected to another program. This is a little more tricky to grasp. We'll have a look at that in just a moment, but before we do, let's look at the way in which output can be redirected to a file. We use the greater than symbol, and we use it in the following way. We run some kind of program, any old program. The program that I've shown you here is the ls-l program. Then we use the greater than sign, and then after the greater than sign, this is very important, after the greater than sign you always put a file name. The file doesn't have to exist. The file can be created at the time, but it's important to note that everything after the greater than sign is treated as the name of a file. Let's try that example right now. So we type in ls space -l and then the greater than sign and then some kind of file name. I've called it listing, but it could be anything. And when I press enter, notice that the ls-l output did not appear on the screen. Theoretically, a file has now been created in this directory called listing. Let's see if we can find it. Do an ls, and there it is, listing. I can then examine the contents of the listing file by using cat or something similar. Cat listing. Now remember that the cat program simply dumps the contents of the file out onto the screen. So whatever output we see will be the contents of that file. So those 8 or 9 lines that you can see on the screen there, they are the contents of the listing file. As you can see, they are clearly the results of an ls-l command. I guess this will serve as proof that the greater than sign caused the ls-l output to go into the listing file. This can be extremely useful. The ability to save the data of any running program, to save the output that you would have seen on the screen in a file, is a tremendous thing. It may not seem particularly tremendous at the moment, but as you become more and more adept at using the Unix system, you'll find more and more needs to capture the output of running programs. Let's now look at the other half of the equation, the ability to send output to another program. If we want to redirect output to another program, we use the vertical bar symbol. which is known in Unix terms as the pipe symbol. I guess the question is, why would we want to do that? What would the other program do with such output? Well, we'll look at the answers to both of those questions in just a moment. First, let's see exactly what we're trying to do here. I'll use the command who. You may not have seen the command who before, except when used in the who am I sense. But there is a program called who. Its purpose is to list all of the users that are currently logged into the system, and then we will redirect that output, or we will pipe that output, to another program that again you haven't seen before called WC. WC is not the toilet. WC stands for word count. And the sole purpose of word count is to count the lines, words and or characters of any input that it receives from any other program or from any files that you specify. Now we haven't specified any files, so the input will come from another program, hopefully. This may not be making sense to you at the moment, so if I give you a demonstration it may make more sense. Let's see what happens if I run the who command just by itself. Now I've got a list of users on the system. How many users on the system? Well, a lot. Is there any way that I can see all of them rather than just the last 23 that I've got on my screen at the moment? Probably there is, but before we have a look at that, I'd first like to find out how many there are. Is there a command that tells you how many users there are on the system? The answer is no, there isn't, but you can kind of make one. If I take the output of the who command and I pipe it, or send it, if you like, to the WC command, then I get a different set of output. I get the output of the WC command, which looks like this: 51, 255, 1851. Now what does that mean? That means that there were 51 lines of output that WC program read, which in turn means that there were 51 lines of output that the who command produced. So if who command produced 51 lines of output, then there must be 51 users in the system. The other two numbers, if you're interested, mean that there were 255 words, which is simply text separated by spaces, and 1,581 characters, including spaces. It is actually possible to modify the behavior of the WC command using one of its options. So I can say instead who pipe to WC, and I use the -L option, which has nothing to do with the -L option that I use with ls. The -L option with WC means don't show me anything to do with words or characters, just show me lines, the number of lines only, L for lines. So again, it's just 51. And I can see the last 20 or so of those 51 users on my screen at the moment. Because I'm logged in, I'm theoretically in that list as well. So what I've actually done here is I've taken two quite simple programs and I've combined them. I've combined them into a command which, when run, will tell me how many users there are on the system. There was no command to do that in Unix, and I kind of created one, I invented one. It's a useful thing to be able to do, and that's why this chapter is called Combining Programs. So let's look at what's actually going on behind the scenes here. When I actually type a command like that, the following thing happens. The shell does all this. The vertical bar symbol, or the pipe symbol, is a symbol that the shell uses. The vertical bar symbol has got nothing to do with the who program, nor has it got anything to do with the WC program. Neither of those two programs even sees the pipe symbol, let alone processes it, and they wouldn't know what to do with it if they saw it. The vertical bar symbol, the pipe symbol, is processed solely by the shell, and this is what the shell does when it sees the pipe symbol used in that manner. It does the following. First, it starts the who program. Secondly, it starts the WC program, and they're both going simultaneously. This all happens within a couple of milliseconds of you pressing enter. Then, while both programs are running, the shell connects the two in such a way that the output of the first program is piped to the second, where it is used as input. If you wanted to draw a diagram of that, it might look like this. You've got one running program, you've got a second running program, and the output forms a sort of a pipe that travels over to the second program where it's used as input. That sort of blue line across there you can think of as almost like a water pipe where the information flows from one program to the other. Using this technique you can connect any two programs together on the following conditions. The first program must produce output and the second program must be a program that takes input. We've seen quite a lot of programs that produce output so far, probably most of them, but we haven't seen too many programs that take input. Let's have a look at the next module where we'll learn more about that.